Today we'll look at 3 different examples of recursion in TypeScript. The first is that you can have recursive references. So here we have 2 types, user and post. User can reference post and post can reference back to user. So that's not an issue at all, meaning that we have a recursive type. So if we use user, which has a bunch of posts and each post has an author, we can define the object for this, and this can be infinitely deep. So here we have a user with posts, which has an author, which is again a user, which has posts, which has an author, which has posts, and that can just go on forever. TypeScript will handle that without any issue at all. Even if user and post are defined in different files, TypeScript can handle that with ease as well. For example, if we have post and then user in separate files, you can import them with the type keyword. So we say import type post from post, and then inside post, we're importing user, import type user from user, and then you can export the type as well. And this means that you won't run into any circular dependency issues when you're running or compiling your code. Obviously, when the code is compiled, TypeScript won't exist anymore. So all of these imports will just be removed. So here, looking at post, I can click through to user, and then I can click back through to post as well. And then TypeScript will handle this without any issue whatsoever. In the second example, let's look at some recursive type helpers. So we have our 2 types here again, user and post, which reference each other. If I would like to turn all the keys of post to optional, I could wrap post in the partial helper. So this is built into TypeScript, and that means I can give it just title, and then I could omit author, and that's not an issue at all. But if I choose to include author, we'll run into an issue, and that's because TypeScript expects all the keys of user to be defined, because partial only works on the top level keys. So whilst it would work for title and the author key itself, it won't work for all the keys within author, so name and posts. So to make this work recursively, we need to define a recursive type, and we can do that by defining our own helper called deep partial. And this is going to use conditional types. So we define our type deep partial and we pass a generic t. We loop over all the keys of t, so that would be looping over title and then author, and then we say, with a conditional type, if that key is an object, so in the case of title, it's not, it's a string. In the case of author, yes, it is an object. We would pass that object back into deep partial and then run the same helper again. Otherwise, we just return key of t as optional because we have the question mark here, meaning that with deep partial applied, now all the fields of author are optional as well. So I could say a name here and then choose not to include the posts key. So this will work recursively as well, so it doesn't matter how deep I make the object, all the fields will always be optional at any level. In the third example, we'll look at another TypeScript helper here, and this one is called flatten. So let's look at this first example. In this first example, we have an array called deep array, and it just has a bunch of values at various different levels. So we've just got an array with an array inside it. We've got 2 numbers, then a string, and then more deeply nested, some booleans as well. And if we have a helper here, flatten, which passes the array in, and here we're calling array.flat, which is just a JavaScript built-in array helper. So array.flat infinite will infinitely flatten an array, but the type that we get out the back of this doesn't look that great at all. Like, what the hell is this? So again, we can create another recursive helper to help us return a much neater type from this function. So let's comment this out, and then we'll go to the solution here. So we have the same deep array, and then we've got a new helper here, deep flatten. We pass in a generic again, and then we use conditional types again to say if the generic passed in is an array, we're going to flatten that array. So we say take any index of our array, and we can do that with t number, and then flatten it. Otherwise, just return t. And obviously this is recursive, so deep flatten will go back into itself and then loop over again and again and again. So if we use deep flatten as the return type for our flatten method this time, when we pass deep array into flatten, the flattened array has a much neater type. So it includes all the types from any depth of the array, string, number, boolean. Now the reason the body is implemented slightly differently is because if I was just to return array.flat here, TypeScript runs into an issue. It says type instantiation is excessively deep and possibly infinite. So TypeScript can struggle sometimes with some of these recursive types, particularly when it comes to things like arrays. So to fix that, we can just apply the result to a temporary variable, return that variable, and then cast it again to the same return type defined here. So that's 3 examples of recursion in TypeScript. Thanks for watching, and I'll see you guys in the next one. Cheers.